So in this video we will be covering hydrogen chloride. So let's start. So the laboratory preparation of HCl, please note down this reaction. It's NaCl H2SO4 and the reaction temperature is below 200 degrees Celsius instead of above it, and the reaction the products are sodium bisulfate plus HCl gas. So this upward arrow represents gas and the downward arrow represents precipitate, but it doesn't have to do anything with this reaction. NaCl is preferred in laboratory preparation of HCl gas since it is cheap and easily available. So in laboratory preparation of many chapters throughout the acids, that these are very important reasons that have to be mentioned. See, for example, why is NaCl preferred? Why is concentrated H2SO4 used? So there are very important keywords that you have to list in the exam papers. So for NaCl, why is it preferred in laboratory preparation of HCl? It is cheap and easily available. Now, concentrated H2SO4 is used since it is non-volatile acid and has a high melting point. So there is a less risk of it volatilizing out with the reactants. Now, concentrated HNO3 is not used since it is volatile and may volatilize out with HCl. Now, it is volatile in the sense its melting point is very low. So it is very volatile, but if you take H2SO4, it is non-volatile in the sense that its melting point is very high. Okay, so let's move on. Now, temperatures above 200 degrees Celsius are not used since. So what are the reasons? The reasons are fuel is wasted, glass apparatus may tend to crack, Na2SO4 or sodium sulfate forms a hard crust, sticks to the glass and is very difficult to remove. Drying agents such as quicklime and phosphorus pentoxide, so please do note the chemical formula. So you have drying agents such as CaO quicklime and phosphorus pentoxide P2O5, since they react with HCl forming their respective chlorides. So if you look at the end of each of these reactants products, you have CaCl2 and POCl3, phosphorus oxychloride and calcium chloride. They have formed their respective chlorides with HCl, as you can see from the left hand side of the entire reaction. Okay, so let's move on. So because CaO quicklime and P2O5 phosphorus pentoxide react with HCl, you don't want that to happen. So that is why these drying agents are not used, and instead concentrated H2SO4 is used. So the reason was given before. Concentrated H2SO4 is used since it is non-volatile and has a high melting point. Okay, so let's move on. Now HCl gas is collected by upward displacement of air since it is 1.28 times heavier than air. So the usual question that is asked in exams is that why is HCl gas collected by upward displacement of air, or there are two types of questions that are asked. One is that which I've mentioned right now, HCl gas, why is HCl gas collected by upward displacement of air, and why is HCl gas not collected over water. Now, why is it not collected over water? Since it is highly soluble in it. Now, properties of HCl are: it is colorless, it has a pungent choking odor, it has a slight sour taste, it is 1.28 times heavier than air. You don't need to remember the exact decimal number point, you only have to remember that it is heavier than air. And it is highly soluble in water. Okay, so let's move on. Now, HCl gas fumes in moist air. Now, why? If you see HCl gas, it fumes in moist air. If you've ever seen HCl gas in chemistry laboratories at your school. So, HCl gas fumes in moist air due to its high solubility and forms mist of droplets of HCl acid. So, this is an important question that can be asked in the exam. Why does HCl gas fumes in moist air? So, this is the answer which you may write in the exam paper. Now, reactions of HCl gas with ammonia. So, this is an easy reaction. You have ammonia in the gaseous state, you have HCl in the gaseous state, which combine to form NH4Cl. S stands for solid, G stands for gas. Okay, let's move on to metals. Now, what metals do HCl react with? Now, before we proceed on forward, I would like to say that each reaction wherein HCl is used, it is dilute. So, I haven't mentioned that all of this is dilute, but please consider each one of these acids, HCl acid, as dilute. Okay, so then you have zinc, magnesium and iron, which react with HCl to form ZnCl2, magnesium chloride and iron chloride respectively, and the gas formed is hydrogen. Okay, so let's move on to the special funnel arrangement and some questions that can be asked from it. So, the funnel arrangement prevents or minimizes back suction of water and provides large surface area for absorption of HCl gas. So, a typical question that can be asked in the exam is that why is the funnel arrangement used to collect HCl acid? So, please do list down the first and second points. Prevents or minimizes back suction of water and provides large surface area for absorption of HCl gas. Now, so this is what the funnel arrangement looks like. This is the special funnel arrangement. So let's move on to the next section. So chemical properties of HCl. The first property is water being a polar solvent. Water being a polar solvent, this is very important. Ionizes the polar covalent HCl molecule into free ions. But toluene, a non-polar solvent, not being a polar solvent, does not dissociate HCl molecule into free ions. Now, there are two types of questions that can be asked in the exam. Why HCl is soluble in H2O but insoluble in toluene? The reason is like dissolves like. Another question that they may ask is, why is the solution of toluene and HCl, why can't electricity be conducted in the solution, whereas electricity can be conducted into aqueous solution of HCl, aqueous solution of HCl in the sense HCl plus water. So the answer to that is because in the solution of aqueous HCl solution there are free ions, because water has dissociated HCl molecule into free ions. But in the case of solution of toluene, it not being a polar solvent does not dissociate HCl gas into free ions, and for conductance of electricity, free ions is a must. So before summarizing each of the reactions mentioned in the screen, what I would like to say is that it is understood that each one of these acids that is used to react with the reactant products like magnesium, copper oxide, sodium carbonate, etc. All of these acids are dilute. I haven't written it, but it is not concentrated, it is dilute. So when you are writing reactions also in exam, please do write dilute. Don't write HCl and leave it alone. So it is very important to write dilute in square brackets underneath HCl, or you could write it in beside the chemical abbreviation of HCl. Now let's look at the first chemical reaction. Magnesium reacts with acids, dilute acid HCl to form magnesium chloride and hydrogen. Now in exam they would ask, mention a proof that So a question that can be asked in this reaction, Mg plus 2HCl gives magnesium chloride plus hydrogen, is that list the reaction that proves that HCl contains hydrogen. Now please don't write that because HCl contains the letter H, therefore hydrogen is there in the chemical abbreviation of hydrogen chloride. You have to list this reaction first. Mg plus 2HCl gives magnesium chloride plus hydrogen, and it is very important to list the upwards arrow that indicates that the reaction's product is a gaseous state and it is hydrogen, which is always a gas. Copper oxide plus HCl gives copper chloride plus water, and then we move on to the carbonates. Carbonates plus acids gives salt plus water plus CO2, and again this upwards arrow indicates that the product is in a gaseous form. Sodium bicarbonate plus HCl gives NaCl, salt plus water plus carbon dioxide. Na2SO3, this is a metallic sulfide, plus HCl gives salt plus water plus SO2, again the upwards arrow, and then we have sulfide. So this is sulfite, but this is sulfide with a D. So sodium sulfide plus HCl gives salt plus H2S, and H2S is in the gaseous state. So these two reactions are very important because they might ask you, there will be some form of, they might ask you to write a certain reaction which involves these two reactions, and they will ask you what is sodium sulfide plus HCl. Now you need to know the difference between sulfite and sulfide. So in T, from T you can get the product SO2, sulfur dioxide, and from D, sulfide D, you get the product H2S. And this is a very hit question because it is asked in every year in the board papers. So it is very important to remember because kids get confused. They list Na2S plus 2HCl gives, and because the major source of confusion is that one product is also same in both the reactions. So there's a very high chance of mismatching both reactions. So you might write the reaction as Na2S plus HCl gives 2NaCl plus SO2 instead of writing H2S. So this is wrong. So let's move on to the next reaction. AgNO3 plus HCl gives AgCl, which is, this is a very important precipitate, which is a white precipitate, plus HNO3. HNO3 is nitric acid. And then we have lead nitrate plus 2HCl gives PbCl2, and this is again a precipitate which is also white, plus 2HNO3 and nitric acid. So in both these reactions we have the production of HNO3. And one more feature of PbCl2 precipitate is that it is soluble in hot water. It is soluble in hot water. Okay, so let's move on. Ammonia, NH3 is ammonia plus HCl gives NH4Cl. Dense white fumes are formed when NH4Cl is produced. Then we move on to the second reaction in this page. AgNO3 plus HCl gives AgCl. As we have studied the reaction before, AgCl is a white precipitate plus HNO3, this is nitric acid. Now if you take this precipitate and you add excess of NH4OH, NH4OH means ammonium hydroxide, in excess, then you will get the answer diamine silver chloride or AgNH3 twice Cl. So please note this formula down, plus 2H2O. Now white precipitate of AgCl is soluble in excess of NH4OH and insoluble in dilute HNO3 and cold water. Now finally we move on to the last reaction of the video. MnO2 manganese oxide plus HCl in the presence of heat. When this reactants are heated, the products that are formed are MnCl2, magnesium chloride, water and chlorine. Now this reaction is very important because in exam they'll ask you, mention the reason, mention a proof that chlorine is present in the chemical abbreviation of HCl. So you could write this reaction down and the examiner would understand that the chlorine is present in HCl because you've listed this reaction and the product is chlorine which is in the gaseous form. So before ending this video, I would like to stress on the importance of these four reactions, 1, 2, 3 and 4, because these four reactions are very important because questions based on these reactions are asked in every year in board papers. So these two reactions and these two reactions. Now we scroll down to the 3 tests of HCl. Now each one of these reactions are 3 tests of HCl, wherein you have ammonia, HCl forming NH4Cl dense white fumes, and you have AgNO3 plus HCl which gives AgCl, which is a white precipitate, and HNO3 is produced. And then finally you take the product AgCl, which is a precipitate, and add excess of ammonium hydroxide, which produces diamine silver chloride, and finally water. A small note that the AgNO3 test, these are the subparts. So this is the first test of HCl, and this is the second test of HCl, which has two subparts, and then there is a third test of HCl in which manganese oxide plus 4 HCl in the presence of heat gives manganese chloride plus water plus chlorine, which is in the gaseous state. So that brings us to the end of this video. I hope you learned something and enjoyed this video. This video will be uploaded on IsEqualTo Classes Shivang, so be sure to check this video out. Stay home, stay safe, take care, and I'll see you in the next video.